Okay, imagine this. A farmer, let's call him Gopal, ancient India, maybe 499 CE. He's looking up at the sky, really worried about the rains, and his daughter's probably wondering about their next meal.
Right. A very real human concern.
And then picture an astronomer wrestling with these incredibly complex calculations, trying to make the sun's rhythm match up with the moon's.
Seems totally disconnected from us now, doesn't it?
Totally. But here's the kicker. The actual math concept that helped that astronomer, it's like fundamentally tied to the security on your phone right now.
It's fascinating, isn't it, how that ancient need predicting natural cycles, like for Gopal and his daughter, actually spurred the invention of really sophisticated math.
Yeah.
And you're spot on, that same core logic. It's still powering so much of our modern world. It's kind of hidden in plain sight.
Absolutely. We've talked about Aryabhata before, his amazing insights into numbers, but today we're really going deep on one specific powerful idea of his, kuṭṭākāra.
Ah, yes, the pulverizer.
The pulverizer, exactly.
And our mission really for this deep dive is to get a grip on the practical power of this, 1,500-year-old math. It wasn't just numbers floating in space.
Yeah.
It was a crucial tool, solving real problems back then, and the basic ideas. Still totally essential for tech we use constantly. We're using insights from that ancient code Modern Mind podcast.
Yeah.
The Pulverizer's Code one.
Right, that's our source material here. Okay, so let's travel back. Pataliputra, 499 CE. The source calls this the kingdom's hope. What was the big problem they were trying to solve?
Well, the main thing was predicting the timing of monsoon rites. Sounds maybe a bit niche now, but back then,
Huge deal, right? For farming.
everything depended on it. They had to sync up the solar year, that's, roughly 365 days, with the lunar cycles, which are much shorter, about 29 and a half days.
And if they mess that up?
Well, think about Gopal and his daughter. Getting the timing wrong meant potentially failed harvests, hunger, instability. The stakes were incredibly high.
Wow. Okay, so getting those cycles aligned wasn't just like an academic exercise.
Not at all. It was survival. And this is where Aryabhata comes in. His work, specifically the Ganitapada, verses 32 and 33, lays out this method, kuṭṭākāra.
Kuṭṭākāra. The name itself, the pulverizer. It sounds so aggressive, like grinding spices or something.
It does have that feel, yeah. But think about what pulverizing does.
Breaks things down into tiny bits.
Exactly. Smaller and smaller pieces. And that's actually a pretty decent way to think about the math. The source puts it nicely. Divide, conquer, repeat, until chaos surrenders to pattern.
I like that. Chaos surrenders to pattern. So it wasn't just math for math's sake.
No, it was a tool. A really practical one for tackling these massive real-world problems. Problems that directly affected whether Gopal's family ate or starved.
So for Gopal, Aryabhata doing these calculations, it wasn't abstract at all. It meant, okay, if the calculations are right, the rights happen at the right time, the rains come when expected.
Your crops grow.
And his daughter has food. It's that direct.
Precisely. It just highlights how connected things were. Intellectual work wasn't separate from the gritty realities of life. Understanding nature's rhythms through math, often a necessity.
Okay, I think we get why it was so critical. Now let's dig into the how. The pulverizer's dance, the source calls it. How did kuṭṭākāra actually work? The cosmic gears analogy seems helpful.
It really is. Imagine the sun's cycle and the moon's cycle are like two gears, right? Different sizes, different numbers of teeth.
Okay.
They turn at different speeds. The puzzle is, when will they line up again at the exact starting point? Kuṭṭākāra was the step-by-step procedure, the algorithm, basically, to find that alignment point.
Like a set of instructions.
Exactly, a precise set of instructions.
And the process involves dividing
Right.
repeatedly and looking at the remainders.
That's key. You divide the cycle lengths, look at the remainder, then use that remainder in the next division, and so on. You keep doing this.
And these remainders form something called the valli, like a chain.
The volley. The source compares it to a chain, or even notes in the musical pattern. This sequence of remainders is the crucial part.
How so?
Because once you have this chain of remainders, you can work backwards through the process. It's like following breadcrumbs back to find the actual numbers, the specific points in time where those cosmic gears, the sun and moon cycles, sync up again.
Ah, okay. So the remainders are the key to unlocking the solution.
Pretty much. The example they give, aligning a 60-day cycle and a 7-day cycle.
Right. It shows alignments happening at day 120, then 187, then 254.
Yeah, it shows it's not just finding one point, but understanding the whole recurring pattern of when they sync up.
Which would be incredibly useful back then. Not just for monsoons, I imagine.
Oh, absolutely. Beyond monsoons, think about predicting eclipses.
Oh, yeah, those are often seen as big omens, right?
Hugely important, yeah. And also just timing other agricultural festivals or religious ceremonies accurately. These things structured their whole society. Getting them wrong consistently,
Yeah.
that could cause real social problems.
Okay, so this pulverizer was a cornerstone of their ability to predict and organize their world. But the really wild part is how it connects to now. Let's talk about the modern pulse.
Right, this is where it gets really interesting. Because that core logic, that pulverizer method, it didn't just vanish. It's actually foundational to a lot of modern tech. The source points directly to the extended Euclidean algorithm.
Extended Euclidean algorithm. Okay, sounds technical. Break that down a bit.
Sure. Remember how kuṭṭākāra breaks numbers down with repeated division?
Yeah.
The extended Euclidean algorithm is essentially the modern formalized version of that. It's a method not just to find the biggest number that divides two other numbers evenly.
The greatest common divisor.
Exactly.
Yeah.
But it also finds the specific whole number solutions for a certain type of equation, what mathematicians call a linear Diophantine equation. And that's precisely the kind of puzzle kuṭṭākāra was built for.
And this has modern uses.
Oh, massive ones. RSA encryption, for instance.
RSA, I've heard that term. Security, right? But how does the old math fit in?
Okay, think of RSA as like the super strong lock on your digital information. Online banking, secure messaging apps, streaming services, they often use RSA to scramble your data. And the engine that makes RSA work, the part that creates the keys and locks, relies heavily on the extended Euclidean algorithm, which is essentially Aryabhata's pulverizer in modern dress.
Wait, seriously, so this 1,500-year-old Indian math is helping keep my bank details safe when I shop online?
Pretty much, yeah. It's the tool that makes the encryption really hard to break without the right key.
That is genuinely mind-blowing. What about AI? The source mentioned artificial intelligence, too.
Yes. So in AI, especially machine learning, there's this field called modular arithmetic.
Modular arithmetic, like clock math, where you cycle back around.
Exactly like clock math. It's all about remainders and cycles. And guess what? That's a direct descendant of the kind of thinking behind kuṭṭākāra. It gets used in AI for things like pattern recognition and even securing the AI systems themselves.
Okay, that makes sense. And quantum computing. That feels even further out there.
It is pretty futuristic still, for sure. But the connection is more about efficiency in solving complex problems. kuṭṭākāra was a leap forward in efficiently solving certain equations back then.
Right.
Quantum computers promise a similar leap, solving incredibly complex math problems way, way faster than our current computers can. It's like maybe a future echo of that same drive for finding efficient ways to handle mathematical complexity.
That's a really neat way to frame it. Not a direct lineage, maybe, but a parallel in pushing the boundaries of calculation.
Something like that.
Yeah.
And it shows this wasn't just some fluke idea. It's a fundamental concept that keeps surfacing, getting refined, and applied in new ways.
It really underscores the eternal legacy, doesn't it? This wasn't just some isolated thing in India.
Not at all. Aryabhata's ideas, including kuṭṭākāra, spread. Later Indian mathematicians like Brahmagupta built on it. Then it traveled through Arab scholars, eventually influencing European mathematics. It's part of this long global conversation in math.
Which is amazing. And bringing it back to the core, like the source does, that fundamental purpose,
Yeah.
bringing order to chaos. It was ultimately about ensuring that farmer's child could eat.
That image is so grounding, isn't it? It connects the abstract math directly to basic human needs, survival, well-being. It wasn't just numbers games.
So if we boil it all down, the key takeaway isn't just, hey, there was this old math thing called kuṭṭākāra.
Right.
It's that this was a super practical tool then solving life or death problems. And remarkably, the principles behind it are still vital now.
Underpinning our digital security, playing a role in future tech like AI.
It really flips the script on ancient knowledge being, just dusty history.
Definitely. It shows how these foundational ideas, centuries old, are still actively shaping our world, often in ways we don't even realize.
Makes you wonder where else these principles are hiding. The source hints at things like maybe Wi-Fi synchronization, or even just the precision of your alarm clock.
Yeah, it poses a great question for everyone listening. Think about the tech you use daily. Where might that core logic of kuṭṭākāra, finding patterns and cycles, breaking down complexity, be working under the hood?
It's a cool thought exercise. And it speaks to the power of mathematical thinking itself, doesn't it? Not just solving one problem in 499 CE, but developing a way of thinking that keeps proving useful across centuries.
Exactly. It's about that fundamental human drive to find order, to understand and manage the world, whether that's predicting monsoons for Gopal.
Or securing your emails today.
That drive connects the ancient mind straight to ours.
A really powerful connection. Well, hopefully this dive into Aryabhata's Pulverizer has sparked some curiosity, made you think about those links between ancient insights and the tech all around us.
To keep exploring those connections, there's always more to uncover.